Hello, we're about to finish up the midpoint sum that we had started in class, and let's get that into the MATLAB code. So here we go. Share that screen. And so here we had just, as a reminder, remember that the lin space for x2 generated the left and right sides of all of the rectangles for the left and right sum. All right, and then it was also the sides that we used, those were also the sides for the trapezoidal sum. So we had to put those in for x and then evaluate the heights at all of those points in line 30. Now it's important to get the midpoint sums. We needed to know how wide the intervals were. So line 32 creates the interval width in the code. So now we're able to use that interval width to generate new x values that are, notice that we took half of the interval width, that are at the halfway points. All right, so this creates a new series of x values that are in the middle of all of those other points that we had before. Right now you're seeing a trapezoidal sum in the graph window. But once we find out where those middle x values are, whoops, we have to put those in for x and evaluate the function at those points. So moving along, we now have the x and y values of all of the middles of every subinterval. Okay, those are now in the code. So we are able to use them. Now, we talked about this in class. The midpoint sums will really be a modification of the left sum. So let me just copy that code for the case one. And we're going to move this down here as case 4. Okay. We want to get everything lined up again correctly. So I'm just going to highlight the entire code and use Control I or a Command I on a Mac, Control I on your Chromebook, and that should realign the code. But we now will have another sum type. This will be type 4, and this will be the midpoint method. So 4 equals, I'll just say MID for midpoint method. So we have a left sum, right sum, trapezoidal, and we just added a mid sum. Okay, so here we are ready to code that in. So we'll need to modify case 1. So first of all, in line 85, it is no longer case 1. That's just a copy of case 1. So we want that to be case 4. There's enough room here to write midpoint sum. So to do the midpoint sum, we actually want to create regions. Let me change my number down to something more manageable, like 3. Okay, and let's do a sum type. Let's do a left sum here.
Malachi Wine, please come down to go
and
to
graph it.
carpool for your swim meet. Malachi Wine, please come down to go to carpool for your swim meet.
All right, sorry about the sound in the background. I'm not going to redo the video, but let me annotate here. So we want to use this point in here. Whoops, let me see, I think I've accidentally selecting. So there we go, I have a pen. I want to use this point here and this point here and this point about here to get the tops of the rectangles, but I want the sides of the rectangles to be in the same place. So the new rectangle should look like this. So to get the corners of those rectangles, notice right here, the x value is exactly the same as it had been for the left sum to get that side of the rectangle. But the y value is the new y3 value. So x3 would be here in the middle. I don't want to use that in order to create the sides of the rectangles. I want to use the old x2 values for the sides, but I want to use the y3 values for the tops. So let me clear that and let's get that into the code. All right, so when I do the plot, I don't want to change where the sides are. So this line 87 of the plot should stay exactly the same because the sides, the X values of all the corners are the same. What I simply need to do is change these Y values. They're now based on the midpoints. So those just need to be Y3s instead of Y2s. And then the area, when we're computing it, is based on Y3 and not Y2. Everything else stays the same. This will now be a midpoint sum. All right. Everything else will stay the same. We're simply using Y3 for the heights. And when we graph this, it didn't work because I never changed my type in the parameters from the left sum. So let me change that now to 4 to be a midpoint sum, and let's see if it works. Sure enough, it does. All right. So we can see that's how we would do a midpoint sum from 1 to 4 with 3 subintervals. If I increase the number of subintervals to something like 12, you can see the answer is going to be pretty good. Okay, let me go back to 3 and explain why it's so good. It is so good because you can see, for instance, in this first rectangle, if I annotate again, there's extra area, or there's area that gets left out here, but there's extra area over there. And so if I were to take this extra area that's here, or I'm sorry, the missing area here is the same as, or is very, very close to the extra area that's over in this other corner. And that's true for each of the rectangles. You can see there's extra area to the left that is almost the same as the missing area to the right. Therefore, this is actually very close to the right answer, even though we've only created 3 subintervals. All right, so if I go to 12 subintervals, whoops, let me stop my annotation, clear it, stop it. So if I go to 12 subintervals now, this should be extremely accurate. All right, and it looks like that answer is getting very, very close to the number 33. So with 12 subintervals, it's that. If I do more, let's go to 24 subintervals and see what happens. It's getting even closer to 33. And from what we learned in class, when this is concave up, the midpoint method will underestimate, just like the trapezoidal method overestimated. So the answer is somewhere between this method, the midpoint method answer, and what the trapezoidal answer gives me. So you can see that the trapezoidal method gives me slightly over 33. The midpoint method is slightly under 33. So I'm getting very suspicious that the answer is actually 33. All right, that ends this video. And go ahead and code that in to your own on your own program, and then you can do the next worksheet.